Hi all, welcome to my channel Engineering Math Support. Today we are going to see the important concepts in Mathematics 1 JNTUA R15 regulation, October supply examination point of view. In Unit 1, we will have the concepts exact differential equation, linear and Bernoulli differential equation, orthogonal trajectories, and application of first order differential equation. As well as we'll have the second part, solution of linear differential equations, second order and higher order. That means these five types are there: e power ax, sin ax or cos ax, x power k, e power ax into v of x into v of x. Here we may expect either the first part we may expect a 10-mark problem, or we may expect one problem from the second part. So if you take the 2 marks, all the definitions they may ask in 2 mark, as well as finding particular integral, finding complementary function are the important concepts. Here they may ask the definition, means they may ask Newton's law of cooling and orthogonal trajectory, and then natural law of growth or decay, define general form of the linear differential equation, or define the Bernoulli form of the differential equation. Like that they may ask the definitions. So now we will see some concepts in the second part, that is solution of linear differential equations of second order and higher order. General form of that equation is given like this: f of b into y equal to q of x. If the q of x equal to 0, the equation is called homogeneous differential equation. Otherwise, it is non-homogeneous differential equation. Otherwise, it is called non-homogeneous differential equation. The solution of this equation is given by y equal to complementary function plus particular integral. We are going to see about how to find complementary function. So take the given equation as star, and here put d equal to m, and where RHS equal to 0 to get your auxiliary equation. Auxiliary equation can be written as, put d equal to m in that and make your right hand side term as 0. So this is called auxiliary equation. Roots will be obtained by solving f of m equal to 0 equation. Based on the roots, we will have the following cases. Case 1, if the roots are real and distinct. Distinct means different. If you consider m1 and m2 are two roots, we can write our complementary function as, each root we have to introduce a constant and write e power of that root. c1 e power m1x, c2 e power m2x is the complementary function. Suppose we'll have three roots like m1, m2 and m3. Each root we have to introduce a constant and write e power form. So cf equal to c1 e power m1x plus c2 e power m2x, c3 e power m3x. This is the way we can write our complementary function if the roots are real and different. Second case is roots are real and equal. Consider m1, m2 equal to some value m. These two roots are same. We can write our complementary function as cf equal to c1 plus c2x into e power mx. Or we can write like this: c1x plus c2 into e power mx. So two roots are there, we have to introduce two constants. Suppose here three roots are equal. Say m1 equal to m2 equal to m3 equal to m. We can write our complementary function as c1 plus c2x. Now three roots are equal. Introduce one more constant and write x power 2 e power mx. So this is the way we can write when the roots are equal. Third case, roots are complex form or imaginary form. Say the roots are alpha plus or minus I beta. That is, first root will be I beta. Second root will be alpha minus I beta. We can write our complementary function as e power alpha x c1 cos beta x plus c2 sin beta x. Suppose if alpha plus or minus I beta repeated twice, we can write our complementary function as e power alpha x c1 plus c2x cos beta x plus c3 plus c4x into sin beta x. So this is the way we can write when the complex roots are repeated twice. Note, we should remember d means d by dx of differential operator. 1 by d means integral. These two you should remember. We will see a problem. Solve 2 into d square y by dx square minus 13 into dy by dx plus 15y equal to 0. So it is second order differential equation. It is of the form homogeneous since your right hand side is 0. Now first we are going to write this in the form of differential operator. For that I am going to take y is common in all the terms. So we will get 2d square divided by dx square minus 13 d by dx plus 15 into y equal to 0. We know that d by dx is capital D. I can write this term as d square 13d plus 15 into y equal to 0. Now we are going to write auxiliary equation. D can be replaced by m and put your right hand side as 0. We will get 2m square minus 13m plus 15 equal to 0. To solve the second order equations, we will have the formula a into x square plus bx plus c equal to 0. Therefore, x equal to minus b plus or minus square root of b square minus 4ac divided by 2a. Comparing with this, you get your a value equal to 2, c value is 15. Applying the formula, we will get m equal to minus of minus plus 13 plus or minus square root of minus 13 the whole square is 169 minus 4ac divided by 2 into a value is 2. So that is 13 plus or minus square root of 169 minus, here if you multiply this 2 into 15, 30, that 30 into 4 is 120 divided by 4. So we will get your root as m equal to 13 plus or minus square root of 49 divided by 4. So we will get 13 root 49 is nothing but 7 divided by 4. Therefore your roots are, first root will be 13 plus 7 by 4, that is 20 by 4, that is equal to 5. And the another root will be 13 minus 7 by 4, that is 6 by 4, that is nothing but 3 by 2. So two roots are real and different. We can use our complementary function as c1 e power first root into x and c2 e power second root is 3 by 2 into x. These are required complementary function. Since it is a homogeneous equation, there is no right hand side. Therefore, your particular integral is 0. General solution is y equal to c1 e power 5x plus c2 e power 3 by 2x is the required answer. The second problem is solve 4d square minus 4d plus 1 into y equal to 0. If you observe the problem, it is already in the form of differential operator. Directly we can write the auxiliary equation. Auxiliary equation 4m square minus 4m plus 1 and put your right hand side as 0. Here we can write your a value is 4, b value is minus 4, c value is 1. Apply in the formula m equal to minus b, already minus 4, minus of minus plus 4 square root of b square minus 4 the whole square is 16 minus 4, a value is 4, c value is 1 divided by 2 into a value is 4. Here 4 plus or minus square root of 16 minus 16 divided by 8. You can simplify this and write it as 4 plus or minus 0 by 8, which implies your roots are m1 is equal to m plus 4 divided by 8, that is 4 by 8. We can cancel and write 1 4s are 4, 2 4s are 8, 1 by 2. Similarly, your another root will be m2 equal to minus 4 minus 0 divided by 8. That is also 4 by 8. That is also 1 by 2. Now your roots are equal. Therefore, your complementary function is c1 plus c2x into e power of x. There is no right hand side term. Therefore, the general solution is y equal to c1 plus c2x e power of x. The next problem is solve d square minus 6d plus 13 into y equal to 0. The auxiliary equation is m square minus 6m plus 13 equal to 0. Put d equal to m and put your right hand side as 0 to write your auxiliary equation. Here your a value is 1, b value is minus 6, c value is 13. Apply in the formula m equal to minus of minus b is here minus of minus plus 6 plus or minus square root of minus 6 the whole square is 36 and 4ac divided by 2a. 2 into a value is 1. Here 6 plus or minus 36 minus 52 divided by 2. If you simplify this, m equal to 6 plus or minus square root of minus 16 divided by 2. We can write 6 plus or minus square root of minus form, you will get I, and your root 16 is 4 divided by 2. Therefore, take 2 as common here and we can write I into 2 divided by 2. These two terms are getting cancelled and we can write your root as m equal to 3 plus or minus I2. It is look like alpha plus or minus I beta. So roots are imaginary now. Alpha value is 3 and beta value is 2. Therefore, your complementary function is e power 3x c1 cos beta x plus c2 sin beta x. Since your right hand side is 0, the general solution is y equal to e power 3x c1 cos 2x c2 sin 2x is the required solution. The next problem is solve d cube plus 3d square minus 4 into y equal to 0. It is also in the form of differential operator. We can write directly our auxiliary equation m cube plus 3 m square minus 4 equal to 0. Previous problems, if you observe, m power will be 2. So we got 2 roots. Now we will have 3. So we must have 3 roots for this equation. The power is more than 2. We cannot able to apply the formula. So we can use synthetic division method. Synthetic division, or we may call it as L division method. To apply this method, first we should write L division like this. We have to write the coefficients of m. So here first we will have m cube. M cube coefficient is 1. Here we will have 1. Here m square coefficient is 3. There is no m, so make 0 m there. Therefore, your m coefficient is 0. Next constant minus 4. Now to find the root here, we have to take the values in the form of trial and error method. 1 minus 1, 2 minus 2, 3 minus 3, like that we have to check. Once the last term you will get 0 means your root will be exact root. Otherwise, you change the value, go with the next value like minus 1, 2, minus 2, like that, and proceed. First, I'm going to try with 1. If you take 1, here if you add 0 plus 1 is 1. 1 ones are, we have to multiply this and we have to write it. 1 ones are 1. And you can add and write 4. Again, 1 fours are 4. Here you add these 2 and write 4. And here you multiply again these 2. 1 fours are 4. Here if you add these 2, you will get what? 4 minus 4 is 0. We got 0 here, so your root is correct. Here your power will be 3. Here I have reduced to power 2. So now we know how to solve the power 2. So I will convert this into the form of equation. To convert this into form of equation, this we have to write it in the form of opposite sign. When you are writing as a equation form, I'm going to write the equation form now. Here plus 1 will be there. I can write minus 1, m minus 1. Already I told you here power 3, m cube it is. Now it is reduced to m square. So therefore 1 m square plus 4m plus 4 is the constant equal to 0. This is the way we can express that into equation form. Now we can write this equation as either m minus 1 equal to 0 or m square plus 4m plus 4 equal to 0. Now we can write here your a value is 1, b value is 4, c value is 4. Apply in the formula minus b, that is minus 4 plus or minus b square minus 4ac. So I have substituted the values here. A value is 1. Minus 4 plus or minus square root of 16 minus 16 by 1 2s are 2. We can write this as m equal to minus 4 plus or minus 0 by 2. That is, first root will be minus 4 plus 0 by 2. That is minus 4 by 2. That is minus 2. m2 equal to minus 4 minus 0 by 2 is minus 4 by 2 is minus 2. So roots are equal now. M equal to minus 2 comma minus 2. Here already we will have one more term, that is m minus 1 equal to 0 is also there. From that we will get one more root, m equal to 1. So this root will be different. These two roots will be same. So therefore your complementary function as c1 e power, for different root you apply different root procedure, c1 e power x plus here for equal root procedure we have to apply that procedure. C1 is already introduced, so I have taken C2 plus C3x e power minus 2x. This is your complementary function. The right hand side is 0, pi value is 0. Therefore, we can write this as a general solution. The next problem is solve d cube plus 16 d into y equal to 0. It is also in the form of differential operator. Directly we can write the auxiliary equation m cube plus 16m equal to 0. If you observe the term, there is a common value m. I have taken out m into m square plus 16 equal to 0, which implies we can say either m equal to 0 or m square plus 16 equal to 0. M equal to 0, m square equal to minus 16. From that we can conclude m equal to plus or minus square root of minus 16. That root, if you are having minus, you will get a I, plus or minus I. Root 16 is 4. So your roots are m equal to 0 and m equal to plus or minus I4. One root will be different. For that you apply the different procedure. You get C1 e power 0x. Here alpha value is 0, beta value is 4. You can write e power 0x C2 cos beta x plus C3 sin beta x. Beta value is 4. So here your right hand side is 0. Therefore your general solution is y equal to C1 plus C2 cos 4x plus C3 sin 4x is the required answer. The next problem is solve d power 4 plus 18 d square plus 81 into y equal to 0. Now I am going to write the auxiliary equation. The auxiliary equation is m power 4 18 m square plus 81 equal to 0. We can use the L division method also to solve this, but I am going to write the term as m square the whole square plus 18 m square plus 81 equal to 0. Now it is of the form sum x square 18x plus 81 equal to 0 form. I can write the term as compare it and write a equal to 1, b equal to 18 and c equal to 81. We can apply in the formula. Instead of x we will have here m square. M square equal to minus 18 plus or minus square root of 18 square is 324 minus 81 into 4 is also what? 324. 324 divided by 2a value is 1, so it is 2. Minus 18 plus or minus 0 by 2. So we will get that value as m square equal to minus 18 plus 0 by 2 is one value, or m square minus 18 minus 0 by 2 is the another value. Therefore m square equal to minus 9. Here also m square equal to minus 9. We can write this as m equal to plus or minus root of minus 9. Here also m equal to plus or minus root of minus 9. Therefore we will get, for minus we will get I, for 9 root 9 is 3. Here also plus or minus I 3. Now roots are repeated twice. We can write complementary function, that is our general solution also. Complementary function is equal to, here alpha value is 0, beta value is 3. We can write e power 0x c1 plus c2x cos beta x plus c3 plus c4x sin beta x. So general solution is, there is no right hand side term, so this is your general solution. Cos 3x plus c3 plus c4x into sin 3x. So these kind of problems you may expect in 2 marks. I hope you can thorough with your complementary function and particular integral. Next video you will see how to find particular integral.